Fires are incidents that can result in catastrophic events for structures and people. These events may occur more often in places with flammable elements and high confluence, such as aircraft and hangars. Being a combination of electrical systems and a large amount of fuel, this is the ideal mixture for the formation of fires. In such conditions, emergency forces have several methods to combat fires fueled by this fuel type. Foam has been used as a fire extinguishing medium for flammable and combustible liquids. Its role is to cool the fire and coat the fuel, preventing its contact with oxygen and suppressing the combustion. This encourages the development of more efficient foams in specialized research centers, such as the Naval Research Laboratory. Where firefighting products are developed and tested as part of their development program initiative to find safer alternatives to current foams. The great focus given to this development has resulted in the creation of high-expansion foams, which are now widely used for fire control and chemical decontamination. Its key characteristic is the high volumetric ratio of air to liquid, typically ranging from 200 to 1 up to 1,000 to 1. This means that a small amount of foam can expand into a large volume, making it highly effective in certain applications, especially in closed spaces or areas where the spreading must be controlled. Because of these properties, these foams are mostly used in places such as basements, tunnels, or hangars. In the latter case, the military forces carry out multiple tests to determine the effectiveness of the foam for their aircraft within these structures. For example, a foam testing process for a KC-135 tanker aircraft done by the Air Refueling Wing focused on analyzing the safety and effectiveness of fire suppression systems in their military hangars. Their first objective was to ensure that the foam covered a taped-out silhouette of the KC-135 tanker aircraft within 60 seconds. Also, the foam covered the top of the placed barrels, which are approximately 3.5 feet high, within 4 minutes. This ensured the foam system could effectively suppress fire in a vertical dimension, covering the entire aircraft. The test results validated that the system would protect personnel, the facility, and the aircraft in case of an emergency. The effectiveness of these products has been demonstrated in numerous tests. However, the systems that use these foams have a certain complexity that requires training to be handled correctly. Emergency services such as firefighters are exposed to these instruments daily, so they must be immediately prepared for any situation, which is why it is ensured that each member performs a series of exercises using the foams. A search and rescue training session offers a rare opportunity for hands-on training in high-expansion foam environments, simulating real-life fire suppression scenarios. Conducting search and rescue in a foam environment is rare but essential for preparing firefighters for real fire incidents. The foam poses unique challenges like restricted movement, reduced visibility, and communication barriers. By practicing under these conditions, the firefighters gain valuable experience to enhance their readiness for future operations. However, even with all of the training and preparation that teams have to use these instruments, there is a risk of accidents or events involving these suppression systems. This is what happened in the Oklahoma Army National Guard base when a civilian contractor accidentally triggered the fire suppression system during routine testing of the alarm and safety system. This caused a massive foam discharge inside the hangars, covering 10 Black Hawk helicopters. The helicopters inside the hangars were undergoing maintenance with access panels and cockpit doors open, which allowed foam to enter these areas. The foam release turned out to be an unintentional but effective safety drill, showcasing the efficiency and volume of the fire suppression system. It also served as an example of how to clean and dispose of such chemicals after a fire. Once the foam has dried or broken down into a residue, teams will typically sweep or use industrial vacuums to remove the solid residues from the surfaces. Advances in fire suppression technology have allowed existing elements in fire departments to be improved. It is well known that the fire trucks used by the military forces have the latest technology to be able to combat these emergencies efficiently. Once new systems are developed, these teams adapt quickly to implement them and constantly update their tools. This is demonstrated by the task of the U.S. Air Force retrofitting its firefighting trucks, particularly the aircraft rescue firefighting vehicles, to use an environmentally safe foam testing system. Such a process involves modifying over 900 ARF vehicles used on runways and flight lines to adopt a new foam proportioning system that was tested using water instead of foam. This eliminates the potential for harmful foam runoff into water systems or surrounding environments. Ensuring a safer process for both Air Force personnel and the communities around air bases. By eliminating the use of hazardous foam in testing, the Air Force is reducing the risk of contamination to drinking water supplies, a significant concern with older firefighting foams. The potential of these vehicles has extended to numerous areas, including the United States Air Force, which has commissioned the development and construction of specialized ARFFs to be air transportable. This responsibility was taken on by E1, tasked with building this vehicle called the Titan AT P-19C, as well as 48 more as part of the order requested by the Air Force. Its main feature is its ability to be transported by a C-130 Super Hercules during rapid deployments on missions, making it a more compact design than other vehicles with the same purpose. Despite its smaller size, these vehicles can carry up to 1,000 gallons of water and 140 gallons of foam concentrate to reduce and extinguish any type of fire. Developing these vehicles demonstrates that fire emergencies can occur in any situation, including on ships and in maritime environments. These incidents can affect any type of vessel, even large and powerful ships like the USS Bonham Richard. This amphibious assault ship was lost to a fire in 2020 when undergoing extensive maintenance operations. This meant that most of the firefighting and damage control equipment was often disabled for repair or upgrade, and when the fire broke out, 87% of the ship's fire stations were inactive. The crew faced significant challenges in mounting an effective response, considering they were inexperienced with in-port firefighting in a maintenance environment, which severely hampered their efforts to control the fire before it spread. These events encouraged the formation of fire brigades with special training to work in these maritime conditions. An example is the Advanced Shipboard Firefighting Training for the Navy, where sailors are trained to handle various damage control situations that occur on ships. Such events also trigger the development of new technologies and products to mitigate such emergencies, such as implementing aqueous film-forming foam systems on ships. These low and high capacity systems are installed on surface ships to protect machinery spaces, fueled vehicle stowage spaces, helicopter hangars, landing platforms, refueling stations, flight decks, hangar bays, fuel pump rooms, and other compartments or areas where flammable liquid fires are likely to occur. Such systems are connected to hose stations and overhead sprinklers, providing extensive coverage in areas where the risk of fire is elevated. With this design, the forming foam systems prevent fires from spreading, minimizing damage and protecting critical shipboard assets. As new firefighting technologies emerge, they demonstrate the great benefits they provide when emergencies occur with aircraft or large vessels. These positive results are another incentive for developing and implementing constantly evolving systems, which allow these disasters to be completely mitigated in the future.